Alright guys, today we're going to look at function notation and using that to calculate using inputs and outputs. You have to have a pretty solid understanding of function notation, and I do have another video on here that really goes into the definition of what a function is and what function notation is. So I would check that out if you're a little rusty on that. Function notation and using inputs and outputs really just requires an understanding of the roles of your different variables. And so real quick, just a reminder, looking at the two examples I've got here, x represents my input. This is something that's plugged into a function to generate an output. On a graph, your inputs are going to be your x coordinates of your points. And then f of x as a whole, that's the function of x, that represents your output. And so whatever you plug in to your input is what you're going to generate for your output, which on a graph would be your y coordinates. And so just going to take a quick look. If you're given inputs and asked to calculate outputs or vice versa, what that would look like. So looking at my example here in red, f of x is equal to 3x plus 1. And let's say you're given an input of 5, and you want to generate and find out what your f of x would be. This is what that would look like. You're basically going to substitute that input of 5 in everywhere there's an x. And so you're going to say f of 5 is equal to 3, and I almost wrote x, but it's 3 times 5 plus 1. Well, then you're just going to work that out. F of 5 is going to equal 3 times 5 is 15, plus 1 is 16, and so your input there was 5, your output was 16. But you're not always just given an input. Sometimes it's actually the other way around. You're actually given an output and asked to solve for the input, and so it's really important to understand the difference. So an output you could be given would be like, let's see, 26 or 27. Let's do 27. Okay, so if your output you're given is 27, you're going to substitute that, instead of in the place of x, you're going to plug that in for the place of f of x, because that's your entire output. And so 27 equals 3x plus 1. You would subtract 1 from both sides. 27 minus 1 is 26 equals 3x. Okay, then you would divide by 3 on both sides, and you end up with x is equal to 26 over 3, which you could work out into decimal form. It's going to be 8 point something or another. But the point is, this would be your input that you calculated here. And the other thing I want to point out with this idea is, as long as you're dealing with functions, it doesn't matter whether they're linear or nonlinear. The solving for inputs and outputs works basically the same way. So looking at my other function here, which is clearly not linear, it's g of y is equal to y squared minus y plus 5. And so if you were given and asked to calculate g of 2, you would just plug in 2 for every y you have. Okay? So then you begin calculating 2 times 2, or 2, excuse me, 2 squared is 4 minus 2 plus 5. Okay, and then 4 minus 2 is 2, 2 plus 5 is 7. So g of 2 would equal 7. Okay, so this is the idea is that anytime you generate inputs and outputs, you plug in the input, you generate the output, or if you're given an output, you can solve for an input.